This video is on dividing polynomials. You can divide polynomials using long division. It's very similar to long division with whole numbers, but instead of thinking of place value, we need to think in terms of power value. So instead of having a hundreds column, a tens column, a ones column, you're going to have an x cubed column, an x squared column, an x column, and a constant column. So let's take a look at an example here. We need to use long division to find 5x squared plus 2x plus 3 divided by x plus 1. So I'm going to go ahead and write this as I would a long division problem. So x plus 1 goes into 5x squared plus 2x plus 3. Now that looks really confusing, but what I want to focus on is just the first term in each of those polynomials. So here I'm just going to look at the x. I'm not going to worry about the plus 1 right now. And then I'm going to look at the 5x squared. I'm not going to worry about the 2x plus 3. So what do I have to multiply x by to get 5x squared? In other words, 5x squared divided by x, what does that give me? That gives me 5x. So x times 5x gives me 5x squared. That's what I'm shooting for. Now, notice that I put this 5x in the x column. I put it right above the 2x because I'm thinking in terms of not place value, but power value. So let's take this term 5x and then let's multiply it by the binomial x plus 1. So 5x times x is 5x squared, and 5x times a positive 1 is plus 5x. So I took the number that I wrote, the term I wrote on top, and multiplied it by what I'm dividing by. Now I need to subtract. 5x squared minus 5x squared is 0. 2x minus 5x gives me a negative 3x. And then let's bring down our next term, plus 3. Now let's go back and remember I'm just looking at x. X times what gives me negative 3x, or negative 3x divided by x is what? And that's going to be a negative 3, which I write on the top in the constant column here. Now I'll take that negative 3 and multiply it by the binomial x minus 1, so that's going to give me negative 3x minus 3. And I want to subtract. Negative 3x minus a negative 3x is 0. 3 minus a negative 3 gives me a positive 6. Nothing left to bring down, so that's my remainder. Now, so that's going to be plus 6 divided by what I was dividing by, x plus 1. So my solution is 5x minus 3 plus 6 over x plus 1. If the result of division yields a remainder of 0, then we know that that binomial divisor, what we were dividing by, is a factor of the polynomial being divided. Recall, if there's no remainder, that means that what you're dividing by goes evenly into the dividend. So here's an example. Is x squared minus 2 a factor of the polynomial p of x equals x to the fourth minus x squared minus 2? If so, we need to write p of x as a product of two factors. So in other words, does x squared minus 2 go evenly into x to the fourth minus x squared minus 2? So let's go ahead and do some long division here. So x squared minus 2 goes into x to the fourth, and I need to, I'm missing an x cubed, so I need to actually add an x cubed here. And I can do it like this, because remember, it's not place value, it's power value, and I need to have a column for each power. Minus basically 1x squared plus, and I don't have a plain old x, so I need to do a 0x minus 2. Now, it may not make too much of a difference in this one, and I have a feeling it isn't going to, but if you are doing long division and you don't have, if you're missing like a term in between there, make sure that you add it as 0, in this case like 0x to the third. Okay, focusing just on the first term of each polynomial here. X to the fourth divided by x squared is x squared, and I'm going to put it up here, kind of in my x squared column. Now let's take x squared and multiply it by my divisor, So that's going to give me x to the fourth minus 2x squared. And it kind of looks like I didn't really need that x cubed, but good practice to put it in there anyway. Now subtracting, that's going to leave me with an x squared, and bring down the 0x, and I'm going to bring down the negative 2 as well. And now x squared goes into x squared one time, so plus 1, and then multiplying that is going to give me an x squared minus 2, subtracting, leaves me with just a 0. So that means that my remainder is 0, so that means that x squared minus 2 is a factor of my polynomial. So p of x is actually equal to x squared minus 2, which was my divisor, and x squared plus 1, which was my quotient. A simpler method of dividing polynomials is called synthetic division, and this uses just the coefficients of the polynomial and the constant term of the binomial, and this is really kind of cool. So we need to use synthetic division to find 4x cubed minus 3x squared plus 2x minus 3 divided by the quantity x minus 1. Here's how it works. So I'm going to take, technically not just the constant term, but what would be my 0 in this case. So if I said x minus 1 is equal to 0, then x is equal to 1. So I'm going to use 1 is what I'm going to use to divide. And we put it into kind of a little box, kind of like a little backwards L-shaped box. Now, to the right of that, let's write the coefficients. So I have 4, negative 3, 2, and negative 3. Notice we're not using any of the x's, any of the variables, just the coefficients. So then leave a space here, a line there where we're going to write, and draw a line underneath that. I'll be filling in some numbers there. Bring down your leading coefficient. And here's how it works. Take the number in the box, times the number that you brought down, and write it there. So it's kind of like a check mark. So 1 times 4 is equal to 4, and I write that 4 there. 1 times 4 equal to 4. Now, instead of as we did in long division subtracting, I'm actually going to add. So negative 3 plus 4 is a 1. And let's do it again. The 1 in the box times the 1 that I brought down is equal to 1, and I write it here. So 1 times 1 equals 1. Add, that gives me a 3. And the last time, 1 times 3 gives me a positive 3. Write it here. Add, and that gives me a 0. And that's my solution. Now let's see, how do we write that? Notice that what I had was I had an x to the third power divided by an x. So my quotient is going to be an x squared. So 4 is going to be the coefficient of x squared. And actually, we usually draw a line right here. The last number is your remainder. So this is kind of cool that my remainder was 0. So 4 is the coefficient of x squared. 1 is the coefficient of x. And 3 is my constant term. And that makes sense because if I had an x cubed divided by x, my solution is going to start with an x squared. The remainder theorem allows us to evaluate a function at a particular value without using substitution. In other words, if I need to find the value of x of a function, the value of a function at a particular number for x, normally I would plug it in and maybe do 5 times whatever that number is to the 5th plus 4 times that number to the 4th and so on. Instead, we can use synthetic division to do that. The remainder theorem says that when a polynomial p of x is divided by the factor x minus a, then the remainder is p of a, what you would get if you were plugging a into that function. So let's take a look at an example of this. Given that p of x is x to the fourth plus 6x cubed plus 9x squared plus 3x minus 3, what is p of 4? Normally I'd have to take 4 and plug it into here for x and evaluate the function that way. But the remainder theorem says that I can use synthetic division. So I'm going to put 4 in my little backwards box, pull off the coefficients from my polynomial, 1, 6, 9, 3, and negative 3, and do synthetic division. And my remainder, the number that I'm going to get here, is going to be what p of 4 is equal to. So synthetic division, let's bring down our leading coefficient of 1, and I'll do 4 times 1, which is 4, and then add those. 4 times 10 is 40, and add those. Okay, 4 times 49 is 196, and then add those. Whoa, getting big numbers here. And 4 times 199 is 796, and adding those I get 793. That's my remainder, so that means that p of 4 is equal to 793. That's a whole lot faster than plugging 4 into this function and evaluating that way. So in this video we took a look at how to divide polynomials, the fact that you can divide two polynomials using long division, which is very similar to using whole numbers, except that we think in terms of power value columns instead of place value columns. And then we also learned how to do the much simpler synthetic division, where you're using the constant term of the divisor and the coefficients of what you're dividing. And we took a look at the remainder theorem and how to use that to evaluate a function at a given value of x.